Thank you for joining us today. And in this video, we have like 3 questions that we are going to go through. But before we start, we need to learn something before we go through the whole process. So first, we need to learn that A is equal to P times ERT. This is R. Now, P is equal to the principal. P is equal to the principal. R is equal to the interest rate. T is equal to time, let me say in years, and then A is the amount and amount n after t years, t year or t years. So let me put it that way. Good. So that is that. Now, when we use this formula, that is the important thing. We use this formula when the question is talking about something like compounded continuously. So that's the key word I need to learn from here. So compounded continuously. So anytime you are reading the question and you are talking about compounded continuously, then it means that we are going to apply this formula right here. Right. Let's learn about the other formula too. A is equal to P 1 plus R divided by N, then NT. So the same thing, P is the principal. The principal is the money that you are going to invest in your account when you open a new bank account, like the initial deposit, right? And then A is the amount that you are going to earn after you have deposited your money in the account and you've run it for like a year or so, right? So now that is the P here. A is also here. R is here. T is here. The new term here is N. Now, what is N? N, we can talk about compounded N times per year. So this one is like I want to invest in bank account within a year, right? So within a year, instead of investing the money in a such a way that my interest is going to be like 1 year interest, I want to do it in a such a way that it will be compounded n times a year. So we can talk about quarterly. So how many quarters in a year? 4. So it means that it's going to compound 4 times in a year, semi-annually. Or let me say, we can talk about, so semi-annually, quarterly, in a year. We can also talk about monthly. Good. So that is the idea. So here we use this formula when the question is talking about compounded quarterly or semi-annually. We can also talk about monthly when it's talking about monthly. So anytime the question is talking about something like compounded quarterly, semi-annually, and monthly, then we are going to use this formula right here. So you see that our N here is the compounded N times per year. So when you take about like when you take like something like quarterly, then our N will be 4 because quarters in a year is like 4, right? So semi-annually, our N here will be 2 because we have 6, making the 12, which is 1 year. And then monthly, we have 12 months in a year. So this one will be what, 12, based on what the question is being asked, right? So that is what's one thing that you need to also learn. Another thing that you need to learn is our T here is in what? Is in years. So when they give you the thing, and let's say if it is in a month, you need to convert it to what? Years before you can go through the process. So these are the 2 formulas that is going to guide us through this process, right? So now let's start. Let's start going through the process. So let's first start with the first one. So now, assuming we have invested $10,000 in an account with continuously or continuous compound interest. So since I've seen this word here, continuous compound, it means that the formula that I'm going to use is A is equal to P E R T. This is what I'm going to use from the question. So this is what we are going to use. Now, I need to look for my various terms A, P, R, and T if it is given. So first, I invested this in the account. So that is the initial deposit. What is the principal? So my P will be 10,000. If after 2 years, so after 2 years means that we have our T, which is 2. That's the time, right? So after 2 years, there is 12,500. So remember, when I was talking about A, we said A is the amount of money that you are going to earn after T years. So here, after 2 years, we are earning this. So it means that when we invest 10,000 in an account after 2 years, this is the money that we are going to get. So it means that the 12,500 is for A. Now the question is, find a formula that models amount in account. So what you need to do is, now if we invest 10,000, we want to find a model in a way that we can know the money that we are going to get after 2 years, after 1 year, after 3 years, after 10 years. So for us to get that, now we have A, we have A, we have P, we have P, we have T, we have T, but we don't know R. So we need to find R, what is the interest rate, so that we can model the account, or we can model the money in the account. So let's go through the process. A is 12,000. A is 12,000. So I'm going to have 12,500 to be equal to P is 10,000. Then I know that T is 2. I don't know R. So when I multiply, I'm going to have 2R. So what I'm going to do here is I'm going to find for R. So what's the first thing that I need to do? I'm going to divide through by 10,000. Divide through by 10,000. So 10,000 will cancel 10,000. And then 12,500 divided by 10,000 will be 1.25, which will be equal to E to R. Now let's learn something here. Anytime I have an exponential function, it goes with len. That is the natural log, right? So now what I'm going to do here is, anytime I have an equation and then I see the exponential function, then I need to take the len on both sides. Anytime I have an equation which involves the len function, then I need to take the exponential function on both sides. So len of E is equal to 1, and then E to the power of len 1 is equal to 1. So that's what we need to know. So it means that here, what I'm going to do is I'm going to pick len on both sides, which is equal to len of 2R. Do you get it? So this is going to give us len of 1.25, which will be equal to. Now let's compare this to the one here. What did we see? We saw that we have len E and there was 1 here and it was equal to what is here. So since we have len E and we have what is here, then it means that that one will be equal to 2R. So that's what you need to know. There was 1 here, that's the reason why we have the 1 here. And we have this one here, that's the reason why we have something here. So that's what we're going to get. So now our R will be dividing through by 2, and R will be len of 1.25 divided by 2. So let's assume that a question is given in exams and then you don't have calculator. Then it means that you need to leave your answer in this form. So now what will be the model? Let's write the model. So the model will be A is equal to, what is P? P is 10,000 E to the power. So now what is R? R is this. Now let's assume that we are not using calculator, so I'm going to maintain everything on top there. So len of 1.25 divided by 2T. Now the reason why I'm putting T here instead of putting the 2, because we learned that T is equal to 2, is that I'm not putting the 2 here in a such a way that anytime I want to find for let me say after some many years. So if it is 3 years, this will be my model in the money in the account. This is 10,000. So if I want to deposit the 10,000 for 10 years and I want to know the amount of money that I'm going to earn after 10 years, then I just put 10 here in place of the T and point this one on the calculator. You will see that you are going to get the results that you are going to get. You get it? So that is the idea. But if we are using calculator, then I think this one should be 0.11. So this one will be A is equal to 10,000 e to the power 0.11 t, right? But if we're not using calculator, then you just need to leave it in this form. So that will be the A, like when we are talking about the A. Let's look at the B. With the B, now the question is asking us how long will it take for the amount of money in the account to double? Good. So this is our model here. I'm using the one that I've simplified here. So we want to look at we want to know the time. That is the time, how long. That's the amount in the account. What is the amount in the account? The amount in the account is what is here. That is at time 0 when you want to do the initial deposit. This was the money that you deposited. So we want to know the time that we are going to go, like the number of years that the money in the account is going to be double. So we are going to have something like 20,000 is equal to 10,000 e to the power 0.11 t. So this is what we are going to get. So we want to look for the time that is going to make this money double. That is after what? After how many years are we going to go in such a way that this amount here we are going to earn like 20,000. What that is 2 times that. So in other words, this one you can write it like 2p is equal to PE 0. Which is the same thing, but we know that the principal is 10,000. So we want to double the amount in the account, the initial deposit, which is also the same as what is here. So now I'll divide through is the same as the first one. I divide through by 10,000. 10,000. Then this one will be 2 is equal to e to the power 0.11 t. Then same idea, I pick ln, which will be equal to ln of e 0.11 t. Then ln 2 will be equal to, as I said, now we know that ln of e to the power 1 is equal to 1. So this will be equal to 0.11 t. Then if I want to find t, I divide through by 0.11, divide through by 0.11, and then t will be equal to ln of 2 divided by 0.11. And this one should be giving us like 6.213 years. So we need to go for us to double the money in the account to 20,000, we need like 6 years and some 2 months before we can double the money in the account. Yes, so that's what we are going to get from this one too as well. So that's what we are going to get. Let me just put this one here. Now let's look at the question 2. Now the question 2, we want to sketch, right? We have a graph and we want to sketch, we want to sketch this. So the simple way of going through this is like we can draw a table. We have our x here and then we have our thing of x here, right? Then we can pick some values on the graph, like some of them. So we can pick like 2, 1, 0, minus 1, minus 2, minus 3, right? So that we can look for their corresponding values. So what I'm going to do is when I pick the x, I'll plug it in this. So when I plug in 2, I'm going to have like 2 to the power 2, which is equal to 4, right? Then this one 2 to the power 1, which is equal to 2, 2 to the power 0, which is equal to 1, 2 to the power minus 1, which is equal to 1 over 2, which is the same as 0.5. Then 2 to the power minus 2 will be equal to 1 over 4, which is equal to, I think, 0.25, yes. And then this is minus 3, which is equal to 1 over 8, which is equal to 0.5. 1, and then 2, and then I think something there. Yeah, so we can put something like that. So what we are going to get here is, I think, 5. Yeah, 5. Good. So now what we are going to do is we are going to plot this on this graph here. So 0 is 1. So at 0 here we are going to have 1. At 1 we have 2. So at 1 we have 2. So we are going to have it here. At 2 we have 4. So we are going to have it here. So we can even think of at 3. When I put 3 there, I'm going to have 2 to the power 3, which is equal to 8. So at 3 we are going to have 8. So I can even add that one to it. Then at negative 1, we have 0.5. So at negative 1 we have 0.5, which is in the middle here. So 0.5 can be looking here. Then at negative 2 we have 0.25, which will be somewhere here, right? At negative 3, so negative 4, you will see that it will be getting close to 0. So the graph will look like this. Yes. So this is what you are going to get at the end of the day. Very sharp. Now, what is the domain? We want to find the domain and then the range. So the domain will be, so the domain is like we are looking at the x-axis. So on the x-axis, we can see that this is going to negative infinity and this is also going to positive infinity. So it's just going. So here the domain will be negative infinity to positive infinity. But what is the range? The range, we can see that the range is on the y-axis, and we see that we never go below this x-axis, and we know that the x-axis is when y is equal to 0. So it means that here we are approaching 0. So the range will be like starting from 0 up to positive infinity. So from 0, then we move up, right? So on the 0, we are getting close to 0, but we are not at 0, and we move up like this. So 0 to positive infinity, negative infinity to positive infinity. So that will be the 2. Now let's look at the next question. The next question is, so you went to a bank and you have 2 options, right? So you are holding $4,000 and you have 2 options. Now option A is that option A has annual interest of 3.5% compounded quarterly for 3 years. And option B has an annual interest rate of 4% compounded continuously. So you see the formulas that we use, the key terms: compounded continuously and then compounded quarterly. So when I pick my initial deposit, which is P, so now I know that my initial deposit is P. So my initial deposit, which is P, is $4,000. So let's look at option A. Option A, we have compounded quarterly. So it means that we need to know the formula that we are going to use. We are going to use A is equal to P 1 plus R divided by N, then NT, because it's compounded quarterly. Then let's look at option B. Option B, we are going to use A is equal to PERT. Why? Because it's compounded continuously. Good. So these are the things that we're going to. So the option here is like, now we have option A, we have B, which is given to you when you went to the bank, and you want to look at, maybe if I want to invest it for some years, which one is going to yield, a better interest or a better income at the end of, let's say, 2 years or 3 years. Then I'll choose from that. So that's the idea. So now let me start with the option A. So option A, I have my P, which is this. Now what is T? T is here, which is after 3 years. So T is equal to 3. What is N? N, remember N, we said N is like compounded N times per year. So here, since it's quarterly, how many quarters in a year? 4. So our N will be equal to what? 4, right? So what will be the interest rate? The interest rate here is R is equal to 3.5%, which is the same as 0.035. Good. So that's what you are going to. So since we have all the information, then A will be equal to 4,000 1 plus 0.035 divided by n is 4. Then the top is n times t, right? So that's what you're going to get. So 4,000, then 1 plus 0.035, this is 3, divided by 4 times 12. So when I do that, option A, I'm going to have something like 4440.81 when I point it on the calculator. Then I need to go for option B. So let me check option B and see the one I'm going to choose. So option B, we have P here. What is R? R is 4%. So R is equal to 4%, which is the same as 0.04. What is T? Now T here is given in months, but we know that in a year we have what? 12 months. So for us to convert this one to year, then we are going to have 30 divided by 12, right? Which is going to give us, I think, it will be like point something there. So like 2 goes here, 15 goes here, 6, and then 3 goes here, 3, 5, 15, 3, 2. So we are going to get something like this, which is, I think, 2.5. Good. So 2.5 years, right? So that's what you're going to get at the end of the year. So like 2 years, 6 months. Yes. So that's what you're going to get. So now that we know our T, we know our R, we know our P, we can calculate for A. So A will be equal to 4,000 e to the power 0.04 times 2.5. And when I do this, I'm going to have 4420.68. So now compare this and this. You will see that we have 4444, but this one is 40 and this one is 20. So there is 20, almost 20 point something dollars that you are going to get on option A than what option B. So for me, I'll choose option A because as an investor, I want to get something good at the end of the year. So I'm going to have something like this instead of this. So I'll choose option A. Now let's look at the last question and then we are done. Now with this one, we have a function here, and the first question is asking how many fish were in the pond initially. So when we talk about initially, let me use bank as an example. Initial deposits. When you go there as initial, it means that you are at time what? 0. You have not moved any year because you are just today. Today, if you want to do an investment, initially it's T is equal to 0. So initially is when T is equal to 0. So we need to find for P of 0, which will be 24,000. Not 24,000, 2,400 divided by 1 plus 23 e to the power minus 0.2 times 0. And then I'm going to have 2,400 divided by 1 plus 23. Now this will be 0. So I'm going to have e to the power 0. And I'll have 2,400 divided by 1 plus 23. E to the power 0 is 1. So 2,400 divided by 24, and I'm going to have 100. So at initial stage, the pond was having 100 fish, right? So the initial will be 100 fish. That's what you're going to get at initial, right? Now let's look at the B. How many fish are in the pond after 10 years? So this is the model, right? So after 10 years, that's when T is equal to 10. So we just plug in 10 into the model here, then we are going to have 2,401 plus 23 e to the power minus 0.2 times 10, and this is the same as 2,400 plus 23. When I multiply this one by 10, I'm going to have minus 2, and when I solve this one, I need to get something like 2,395 fish. So after 10 years, the fish is going to double. So from 100 to this 2,399 fish after 10 years. Then the last question is, what value does the population approach as time goes on? T is approaching infinity. So as we put the fish in the pond for a very long time, what happens to the function? Definitely, let's see what is going to happen. So this one is like final limit of the function. So we want to find limit as t is approaching infinity of the population, which is p of t. So this is the same as limit t is approaching infinity, 2,400 divided by 1 plus 23 e to the power minus 0.2 t. So I'll plug in the infinity. I'll have 2,400 divided by 1 plus 23 e to the power minus. So, okay, let me write this again. 0.2 times infinity. So what am I going to get? Let me shift this one small. Wait. So I'm going to have 2,400 divided by 1 plus 23 e to the power negative 0.2 times infinity here will give us negative infinity. Now note that e to the power minus infinity is the same as 1 divided by e to the infinity. So 1 divided by a very big number is equal to 0. So it means that e to the power negative infinity is equal to what? 0. So this is going to give us 2,400 divided by 1 plus 23 times 0. And this will be 24,000. No. So let me write it up here. Okay, I can clean this and shift this one small here. Good. So I'm going to have 2,400 divided by 1 plus 0, and then this one will be 2,400. So at a very large population, when t is approaching infinity, we are going to have 2,400 fish. Good. So this is the end of the video, and see you in the next video.